Today we are going to talk about systems, and I'm going to compare what we call conventional way of building and the super system. Super system would be availability of building components on the market, all of them coordinated in a way that they can be produced in advance and changed one against the other, so that there are different firms, different actors on this market that develop competing products, and an ideal market situation would be there. And to get to this ideal market situation, modular coordination has been attempted. So how to develop a sort of grid that all of these building components can be fitted in. Let's try to take a look at this. So here you can see the door in a finished building, and the door has been prefabricated and put in this place, but the rest of the building has been more or less assembled on site. So these are drywalls here. You can hear that it sounds hollow, and the drywall is normally assembled on the building site. But at the base of the drywall are studs and plates, and these are assembled then on the building site according to certain rules, and the results will be predictable in terms of phonetic performance and so on. So the door that I'm showing you is a sort of subsystem inside a bigger system. And in this case, the building is not so much a systems building, but rather a conventional building. But the door is a system. So the rules of the system are set in advance, and I can have a bigger door, smaller door. I know where the door handle will be, where a window should be, where the hinges are. So all of this is known in advance, but it integrates in a rather conventional building. So the big question is, how can we extend what we have seen in the example of the door to the whole building, as to increase the part of the building activity that takes place in the factory and decrease a little bit what's taking place on the building site, as to achieve more performance in the sense of better quality, shorter building times, and better conditions for the workers that are assembling the building on the building site or in the factory. So the door that I've been explaining to you is integrated in a conventional building. And the opposite of this conventional building is industrialized building. And the ideal form of industrialized building is what I call the super system. So what does a super system consist of? It's in fact the whole market being one big system where industrially prefabricated parts can be exchanged from one building to the other. So in terms of the door, the market already is a sort of super system, because I can buy a door from one manufacturer or the other. But the idea would be to extend this thought to the whole building and to be able to exchange wall systems, floors, ceilings, whatever, inside this building system in one big market. So I'm trying to divide the building in elements, and then these elements I'm trying to standardize as to get a market which is sufficiently big. And then these standardized elements would be interchangeable and could be produced by different manufacturers. As to be able to do this, I will divide the building into primary, secondary, tertiary structure, and then I will be trying to coordinate these different elements in a way that they can become interchangeable. So the way that most people have been thinking of to coordinate these elements was a grid and a dimensional system in which elements then could be interchanged. So the door that I've been explaining to you would be in such a closed system, because all the elements of the systems are known in advance. And if I would have the whole market as a system, this would be an open system where I can interchange different products from different manufacturers inside a coordination system. And the objective, as we have been saying, is the industrialization of the building process. To get there, we want to cut the building into elements, and now we are trying to find a system where it would be possible to prefabricate the different parts of the building in an attempt to create more competition between different actors on the market as to achieve the same advantages as Henry Ford could achieve with his Model T and production line concept. Here I'm inside a building that belongs to LMU, Ludwig Maximilians University in Munich, and you can see that it has been planned on a square grid. It's a band grid, not a line grid, because the depth of the walls have been taken into account in this grid. You can see that the separating walls are planned on these bands here, and you can see that the primary structure has been planned on a line grid, which you don't see neither on the ceiling nor on the floor, but it arrives in the middle of the band grid. So it's completely separated, and you can have entire wall elements when dealing with the color. You can see that this band grid projects on the facade. So you have the window elements in between. You could arrive with a separating wall against the facade. And the balconies are suspended. These are prefabricated elements. They are suspended from the primary structure, which is behind, and hopefully it's insulated. And so this is a typical facade for flexible building, where on the inside you could position the separating walls in one way or the other on this square grid. So what could be the problems with this type of approach? As you know, buildings are part of the collective memory, so to think everything from the market does not correspond to this cultural approach. And the built environment is part of life's quality, so to reduce life's quality at market situation is also something which I consider rather difficult. You know that during history there have been different plot sizes. They might be triangular, so that might not correspond to the type of modular coordination that we are looking for. We might have contextual restraints, the thing might be in a slope. Buildings are long living. Yeah? Normally you think that concrete parts of a building last about 100 years. So that's something completely different than an automobile or a cell phone. And buildings are big, so they are huge, and they are heavy as well. So, what can we try to handle these problems? One would be, I told you already, to divide the buildings in prefabricated elements so that the dimension of the things that we want to produce in a factory would be smaller. We could also deny history and say we are starting from a very objective, neutral point where everything that has been before doesn't interest us, which has been done in the 60s and 70s actually. We put an accent on quantity instead of quality. How many apartments, and not what the quality of these apartments is. We could have ideal building sites, flat ground, and then or flatten a slope. Yeah? Try to flatten it out as to unify the topography. We could try to use to neutralize the climate by technology, like air conditioning or things like that. We could try to make buildings temporary to reduce the lifespan. We could try to use the weight of the buildings, make them lighter. We could try to unify the programs by giving the buildings a little more flexibility. For example, I would like to live in my office because it's a nice room, it has sun, it's big, but unfortunately I have to live in my apartment, which is nice as well. Don't be worried, but this could be used in different ways, this space, and if I had a bathroom next to it, it could be an apartment as well. And we could unify the building structure, having the same elements for different types of buildings, and well, that's about it.